got a piece of 1 3/4 bar in the chuck there and set up in the 4-jaw. I just dialed it in, it's within sort of half division, so 0.005 millimeters. I'll just face it off and measure it up and skim a little bit off and get to our size ready for threading this. What I'm going to do is thread it all the way down, and then we'll turn some plain portions in the centre of the 2 threads there. Then I can bore it, taper it, part it off to length so that it is one of them. It'll be that way. It'll be obviously a bigger OD, bigger thread on there, 1 3/4 as opposed to 1 5/8, and then stepping down to that diameter as the original Triumph spigot would be. And these have got a slight taper on the inside just to feather them in there, and obviously a couple of holes through for a small Tommy bar to tighten them up. They do need to bottom out on that face from what I've learned, so we'll make sure we do that and thread lock or do something with the threads in there. So let's get this faced up ready. Right, that quickly faced off. Doesn't have to be brilliant at this stage. Check of the diameter there. 1747 so just under 1 3/4. And I'm getting on the, just measuring the tap there, just as a guide for me, 1754. I'm just slightly over 1 3/4. 747, so we're a little bit under. So we'll put the thread straight on that. Basically, it's close enough on our dialing in to get away with that, I think. What I have got here, I did make a while ago, is a sort of a test nut. It's a piece of aluminium plate with the 1 3/4 thread in it, just to check as we're going along, get that screwed on there, so we can set up for thread cutting. Hello, this is Berry. This is our latest edition. Unfortunately, if you've been following the videos, our 2 younger cats, one of them passed away last year, and another one of them passed away while I was ill. Aortic thromboembolism in both of them, sadly. So there's Berry. He's the new boy on the block, and just been starting to go out for the last couple of days. Very curious and learning about the world. Right, this is a take 2. That first one wasn't very successful. I've put my compound slide round the right way this time. I was over here for some reason, blonde moment there. I'm set up with a high-speed steel tool bit. I've already put a piece on there that's turned down to the diameter of the exhaust stub. I'm going to fully thread this end and then turn a plain portion in there so I don't waste the material. I'm set up for threading on 16 TPI on the thread cutting gearbox, D and A on there, and we're on English on that selector lever as before. So let's have another go. So at this point I've touched off there, I've zeroed the cross slide, I've zeroed the compound slide, I've put a little bit of cut on with the compound, set the hand wheel on the cross slide to 0 as well. We're on 16 TPI. A little bit of cutting oil. And I'm going to go right to the end and drop off the thread there. So, and I'm looking at the thread dial indicator, dropping in on 2 there. Backing out on the cross slide, back to the beginning, past the start point, back in on the cross slide to 0, and we'll do a quick check of the thread pitch. There it is, and yeah, 16 TPI. Okay, more cut on with the cross slide, compound slide, sorry, on 2.5 divisions of there, which is 0.25 millimeters, but we're at an angle, remember. And we're on 2 again on the thread dial indicator. Off at the end. And another 2.5 divisions. And we're back in on 2 again. threading indicators come round to 4, we're going on 2 or 4. Out with a cross slide. Cross with that. Back in with a cross slide to 0. Also checking on the digital readout here. And a little bit cut on. Just putting half a division on this turn. And wait for the number to come up. Forward again. Try and keep my belly out the photo, out the video. Right, after a few more passes, there we've got it. It's a nice, very snug fit actually, which is about what you want for going into the exhaust port. Right, there it is with a bit of plain turning. We're just down to that diameter there. So I'll drill and bore now. So we're going to end up that way round with the oversized. Move the compound over and pour a slight chamfer on the there's one well underway. When this is out of the chuck, I'll put it in this end and face that up and put a taper on there. Just face this off. Right, there's our two adapters, spigots, whatever you want to call them so far. Was a bit awkward doing the opposite side of that. I put it in the the outside of that. I put one of them, I put in a small lathe. Just held it lightly by the threads to do the opposite taper because of the way I did them on the bigger lathe. But we've got that screwing in by hand. It goes down a little bit further than that, it bottoms out, and it's the same on the other one. It also screws in by hand. So I've just got to put the Tommy bar holes through now and then get them tightened in there. Set up in the milling vise here, bit of lead just to protect the threads, centred between the two outside faces of the jaws. the pilot drill done, and that one's about that 5/16. Drop that down. And we'll do the other one the same, and I'll just deburr them holes. There's our two parts with the holes drilled through. So we've made sure we've got a little bit of thread relief there at the end to allow for the thread not quite being to the bottom in the exhaust port of the cylinder. Clean inside the cylinder head. Straight cleaner, and we'll clean the clean those as well. We'll get the oil off. And with them cleaned off, we'll put some of our favourite green retain around there. It's fairly high temperature. There is a higher temperature Loctite version available, but I'm not paying 60 odd quid out for one tube of Loctite for one job. The most important thing for these is that they actually bottom onto the machined flat part of the exhaust port there. So plenty of that on. And we've got a screwdriver that fits nice in there, in the holes. Just drop that down. And we can see that the Loctite's been taken down with the thread there. We'll put that through that way. And we've got a piece of tubing there. Give that a good tighten up. And straighten the screwdriver as I go along. Clean off our excess. And if I hold that steady there, so as you can see just about in there that this has bottomed out well onto the mating surface there, and we've got no threads sticking up above the machined area, so the exhaust will fit on, slip over that nice with a rosette around it, and job will be fine. So I'll turn this head round now and I'll do the same for the other side. There we go, with them both in place. I've got to clean this bit of weld up still and do some other bits and bobs on this head just as practice. This is basically a bit of a scrap head on experimenting with. It's had a centre plug conversion on it as well, and there's a broken off spark plug in there that I want to try and get out. So yeah, so far so good. We've got the spigots repaired. Right, it's not easy to get in to this with the camera to this at all, so bear with me a bit on it. What I'm trying to do here is remove a 10mm spark plug, but I can't even see very well. To get in. I've tried the usual screw extractor bit and that isn't working, so I'm just going in here with an 8mm milling cutter. Eight mil slot drill. Hopefully I'm about on centre with it. Seems to be taking the threads out. Okay, I've had to revert to a drill bit, which I didn't really want to do because of the lack of rigidity. It's the only thing I've got to get deep enough. Again, I've set the depth stop up to the other hole there. Shot it right through. Right, we're to the bottom. All that's left now is a little thin shell of the original spark plug. Right, we've peggled the bits out. I'll show you. There, remains of the spark plug. Camera. There. Not easy, not without some collateral damage, as you might call it. So I'll just run a tap down there. That's cleaned up some of the thread. It isn't without damage. You'd now get away. We can see that one side's retapped, reasonable. That's usable. The other side, you can see there. Process of trying to get the bit out. That hole has damaged that side. It's not too bad on that side. I'd helicoil that now. I won't at the moment because I've got a helicoil kit and I'm still wondering where this head sort of ends up. Whether it's sort of in the scrap bin or otherwise, because that spark plug hole also wants helicoiling. The other side would probably clean up. So yeah, a lot of damage on this one. And now the worst bit, horror of horrors, underneath. Clean that out a bit. Where them little bridges were has broke through, which exposes the spark plug, and it'll get the spark to the mixture sort of thing, but it's also exposed the edge of the valve seat. That isn't very good either. So yeah, I'll carry on cleaning it up and see where we end up. Right, I'm just going to blend this a little bit more and then we'll bead blast it, clean it up. As you can probably see from this video, it's done at separate times. I don't keep changing clothes midway through the video. Well, this is sort of a week or so on from probably the previous recording. We'll fit it in as and when I've got time. Right, I'm going to have an attempt at filling that with a little bit of brazing alloy. So obviously it's going to send this a different colour, but hopefully that'll clean up in a bit. So we'll have a little go at that next. Okay, what I'm going to be using is this called Alutite. This comes from one of the auto jumbles or trade shows or whatever it was. There's the details on it. You can find YouTube videos on it, and in the demonstrations he uses a little bit of extruded aluminium, and the demonstration is quite good, but it's a very small piece he's using. Obviously the problem here is trying to get the heat into a larger workpiece, so we'll see how it goes. See, it melts with very low temperature. Yeah, I managed to get a little bit of that brazing alloy into them. So there we have the finished article, lightly sandblasted. It wants a little bit more yet, and it wants a few more thread repairs. But we've got good exhaust stubs, in well, solid, butted right up to the recess there on both sides. Them centre spark plug holes have been cleaned up, so actually the spark plug's exposed more now than it was when it had the little tiny slot. How much compression that loses, yet to be seen. It's probably already been skimmed a little bit because it's very close to that bottom fin. Probably could stand a little bit more. The holes where the tap threads were for the previous repairs have been filled with that low temperature alloy, and it's masked them up fairly well. I mean, it could again stand a little bit more fettle in there to blend them in, but it's sort of done the job on both sides there, and the holes from the top are fairly well hidden, considering the state of the head to begin with holes, broken bits under there, snapped off spark plug, worn out exhaust port threads. It's not come out too bad. That's it, job done. Triumph head repairs. Say a lot of it was a bit experimental to see whether I had the facility to do it, and yeah, I think the answer is that part of it, no problem at all. But it'd be better to start with a much better head in the first place. So there's another one done, as I normally say, and see what the next one is. I'm not quite sure yet. I've got a pneumatic cylinder to look at there. So probably something slightly less interesting than the Triumph head, but that might be the next job. So as ever, thanks from me, thanks for watching, thanks for subscribing, and thanks for all the wishes of get well and support from the subscribers following my my illness there. So as usual, bye for now.